All right, so we drew a circle. Let me get my diagram down here. Drew a circle. I got two chords that intersect at E. 1, 2. I got AB. I got CD that intersect at E. Let's see. AE is x plus 1. EB is x. CE is 2. And ED is 3. Let's rock and roll here. Two intersecting chords. We went over theorem yesterday. The parts of those chords, what do I have to do with the parts of one chord? Multiply them or add them, subtract them, divide them? Multiply them. So in this case, 2 times, what's the other part? 3. It's going to be the same as the two parts from the other chord, which are x plus 1 and x. That's what our theorem, you guys that missed out on yesterday, if two chords intersect, their pieces multiplied together equal each other. All right. All right, here we go. 6 equals x squared plus x. What are you going to have to end up doing here? That's why I picked this one. Yep, got to factor. Cannot do so unless what? We're not ready to factor yet. One side equals 0, so everyone boot that 6 over. For time's sake, I don't have time to do the old quadratic formula, so yeah, I'm going to ask you to factor this into 2 parentheses. Two numbers that do what? Oh boy, we're in trouble already. Multiply to -6, but add to 1. That's what I'm going to ask somebody right now. Multiply to -6, but add to 1. Find those numbers for me. 25, we got those numbers?
-2 and +3.
+3 minus 2. All right, 2 answers would be what now? 2 answers. That was good. I'll come back to you. X equals. 1 through 29, let's go. And nobody's sitting next to you. 18. What are my 2 answers? 2 and -3. Anybody want to talk to me about anything? Did you guys draw a diagram at the beginning? What's wrong with one of the answers? I can't have a negative length of a chord, right? So go on. And just let me go back. What was it asking for? Value of x. Yep. 2. All right. Questions from you guys? That was just a quick review of what we did yesterday. All right, let's finish this up. Oh boy, another fact, huh? Okay, if you, in a circle, if you have 2 chords that are parallel, the arcs in between them are congruent. Let me say that again. If you have 2 chords that are parallel, the arcs in between them are congruent. They're all good? Not too bad, that theorem, right? Only if they're parallel, though. All right, if they're parallel, the arcs in between are congruent. All right, let's go. Here we go. Let's try practice it out. CD is a diameter. AB and CD are parallel. Using this new theorem, tell me the 2 arcs that are congruent. Still rocking. 26, there we go. Don't even have one. Do we, Jack? Yeah, we do. What 2 arcs are congruent? If 2 chords are parallel, the arcs in between are congruent. Nice job. Appreciate it. All right, how are you going to find arc CA? Now, this is just circles now. I can't help you here. This is all circles. How can I find arc CA? I gave you AB was 80. Where are you going from there? Oh, 25. Good. So arc CABD. This one on the bottom is a semicircle. I'm listening.
So then you're going to subtract the 80 that you have.
Yep. So you got 180 minus 80. I have 100 degrees left. Yep.
Since they're even, you divide it by 2.
And there you go. Arc CA will be 50 degrees. All right. Two chords are parallel, arcs in between are congruent. All right, let's move on to another one here. I got another A, B, and CD parallel. Name the two arcs, please, that are congruent. First, got to start there. 7, good job. 1, name the two arcs that are congruent. AD, BC, so I should probably throw an 80 spot up here, right? For BC, everyone all right while I'm labeling BC 80? And then find arc CD for me. 24, find arc CD, help. Yep. And then you're going to do what with that? Here you go. 360 minus 80 minus 80 minus 60. And then when you get that measure, let me know. 26. We're staying over here today. $1.40. Thanks, Jack. Chords are parallel. Arcs in between are congruent. And last one. Ooh, this one looks nasty. A, B, and C, D are parallel. Okay, everyone stop. 5, what, great job. 23, what two arcs are congruent? Okay, so I'm going to put a 30 on AD since they're congruent. And take a look, I also told you DE was congruent to CE. What's arc DE now? Ooh. I got to use a theorem we used one of the first couple days of the unit. Uh, 27. What are DE and CE in the circle? Okay, we had a theorem first couple days. If the chords are congruent, so are the arcs. Done. So DE and CE are the same measure. What do they all add up to, Anthony? Okay, so 30 plus 50 plus 30 plus the two arcs I know are congruent, X and X, add up to 360. The chords are congruent, so are the arcs. Congruent chords imply congruent arcs. And then you end up solving for X whenever you have it there. 10, you have it. 125 degrees. Full advantage of this opportunity. You can go on to the homework that's due Thursday, or you can get your Chromebooks out and try one of the 46 problems with whoever you want to work with and ask me questions. But again, I'm giving you this time. It is full on review or homework for Thursday. Nothing else. Nothing else. So you decide what you want to do. All right, work on the homework from Thursday or get some of those review questions down or just review for the darn quiz tomorrow. Call me over with any questions.